Yeah, I will skip the team name and team members. Next is content. We divide it into three categories. Uh, First is introduction. Second is design and experiment result. Third is conclusion. Yes, let me explain the introduction. Basically, our project designed a system that can measure distance and speed in real time using FMCW circuit in the S-band. In fact, we designed the circuit-based distance and speed diffraction system, and also designed and conformed the system that measures in it real time. As you can see here, we have various RF devices such as VCO, OPAMP, LPF, and so on. As I said earlier, you can target objects and know the speed depending on the distance. And I will also tell you the benefit. First, radar systems are very expensive and complex, so it's very difficult to experience radar at the undergraduate level. However, our system can implement FMCW radar at a low cost with an educational system, and it also provides high reliability. Yeah, I think that experiencing this system will actually allow students to have a high level of experience and boost their confidence. Yeah. Yes. Next, I will tell you about the design and the result of the experiment. Yeah, first, I will show you the theory and the test experience. In order to measure the distance using the signals received from the S-band FMCW system, you basically need to know the resolution of the distance. Yeah. Here C is the speed of the light, and delta F is the frequency modulation bandwidth. If the received signal is received after emitting the S-band FMCW signal to the ADC through the mixer and the RPF with frequency, yeah, which varies depending on the distance of the object, can be measured. In order to get this RRE, you need to get RCS value, but in order to actually get the RCS value, so you need to know the radius and wavelength and use it to get the Gibbs pair and get the constant value. Yeah, you can get the target value by multiplying this constant value by S11 per meter in the above the equation. So the RRE can be obtained through this target value. So the RRE will vary depending on the target value. The following is a circuit diagram information. The RF stage is a high frequency stage and is used to secure the bandwidth of the signal, and then the second stage, electronic stage, is used for signal processing. As for the operating characteristics of the radio circuit, the RF stage uses the initial VCO to input the electronic stages function generator into the V-tune of the VCO to generate the signal by varying the frequency. And the other photo is the RF amplification of the transmitter, mainly use a power amp, but the radio system in the current text uses an LNA that has a high gain but produces a small output because it is too safe to use a high power device for research and experimentation. It was confirmed that the LNA has a gain of about 15 dB and a VCO output of about 1 dBm. So when amplifying the received signal with the LNA, an output of the 16 dBm is produced. Using this signal transmission output of 13 dBm could be obtained by using a 3 dB divider. The signal received at the receiving end has a very small power, so the gain was able to purchase a better TQP3M9036 LNA chip and manufacture a circuit of the substrate to increase the received output to 20 dBm. Yeah, so that is really hard question. And we are going to buy canned food. Is it easy to get around when the radius is 51 millimeter high and 119 millimeter? The refraction coefficient of the antenna obtained through tuning was observed at minus 36 dB at 2.45 gigahertz, and the antenna gain as a result of the simulation was also 8 dB. Yeah, which was just to have a suitable gain for this project. In the actual production, I felt a failure because it came out like 7 dB, 6 dB, but the surface of the can was uneven and there was a problem with that it was grounded with the n-type adapter. When I flattened the surface and coated, I got a satisfactory result of 8 dB. It was actually manufactured and conformed the frequency characteristics of the two antenna by connecting them to the VNA. So the frequency characteristics had a center frequency characteristics of 2.553 gigahertz, and the refraction coefficient characteristic was minus 39 dB. Therefore, the voltage range of the function generator was fixed at 5 to 10 voltage, and the frequency band of 300 MHz was swept at 2.45 GHz to 2.775 GHz, according to the center frequency of the antenna to prevent refraction loss. The number 4 is overall system implementation and experiment result. Yeah, so the figure on the left shows the overall configuration of the system. Yeah, so to configure the RF and antenna and IF and were soldered and soldering plates to fabricate a circuit. Now, since the actual antenna was manufactured to configure the entire system, the signal entering through the ADC was FFT to check whether the circuit was operating well before signal processing to check whether the bit frequency. Yeah, so there was a measured according to the actual distance. Therefore, a program was written in conjunction with MATLAB to directly check the signal seen in the ADC by measuring it in real time and converting it into a distance. Using MATLAB GUI function used the app, I wrote it and checked the result, and it's a brief code and an app that runs. At this time, the code would be implemented using the HQ and Vigilant 2 box with the add-on support by MATLAB. Since the IF frequency band filter was limited to 20 kHz, when implementing the distance measurement algorithm, the sampling rate was set to 14 kHz to write the code to check the spectrum up to 20 kHz. But the picture of the left shows the distance spectrum according to the distance of each object in the non-marine corridor with the radar. And the next photo on the right posted the post take in the alleyway. A total of 3 corridors were measured and the leader was moved in real time to approach the object. As it approached the object, it could be seen that the axes and distance of the distance spectrum gradually decreased. In the case of the corridor 1, it was measured at 25 meters, and it can be seen that it is gradually decreasing. There was no object between the worlds, but the spectrum was seen. This was confirmed by the harmonic spectrum of low frequency noise, which is judged to be a system limitation. Yeah, so and next two is distance to the water purifier. the bending machine and the firewall was measured, and the wall, which is the fallback, was also measured. In the case of the back wall, it was not well visible by the spectrum of the object in front, but it was measured when it was close to the about 44 meter. It was confirmed that the radar system manufactured through this can measure the distance spectrum of various objects. In the case of the corridor 3, it was added to measure the farthest distance within the normalizing pipe. At this time, it was confirmed that the maximum distance of 5-6 meter and the barrier distance of 3-4 meter were properly measured. Therefore, through the experiment above, it was confirmed that the system distance measurements work well. The picture of the left is the speed measurement result data. The speed of the object can also be measured if the tune of the VCO is fixed in the current system. That is, if the transmission signal is changed from the frequency modulate signal, FMCW signal, to the continuous wave signal. Yeah. So therefore, when designing the IF stage, the switch is connected to change the CW mode and FMW mode when the signal is input from the modulate to the VCO. On the right is a measurement of vehicle speed on outdoors 30 km/h speed limit road. The spectrum was measured by a person moving reciprocally in front of the radar. The initial speed was fast, then the speed was reduced, and the speed was fast again. It was confirmed that the speed was flat at 4 meter per second and 14.4 km/h in the frame from 10 to 16, and it was plotted slowly and 1.5 meter per second and 5.4 kilometer per hour in the frame from 60 to 80, and again at 3 meter per second and 10.8 kilometer per hour in the frame from 80 to 90. Therefore, the degree of human speed was measured and the speed of the vehicle was measured. Next, I will show through the video. Yeah, the first video is measured in the hallway. The second video shows changes in distance data in real time. Yeah, last one is conclusion. So in this project, although there were some errors due to the limitation of the system, the distance of the object could be measured in real time. In addition, the speed of the object was also able to check the speed of 13 km/h or less in real time. Based on this design and experimental experiences, it can be an opportunity to learn from more deeply about later design, which was only learned theoretically in class. Since various parameters are important when designing radar, there were many things to consider carefully. In addition, based on the antenna design suggested by MIT open course, the antenna could be implemented at a low cost. Thank you.